So a body performs torsional oscillations according to the law phi is equal to phi naught e raised to power minus beta t cos omega t. We need to find angular velocity phi dot, angular acceleration phi double dot at t is equal to 0, and moments of time at which angular velocity becomes maximum. Let's just plot the graph. It's a very interesting graph here. So in this case, you can see at t is equal to 0, amplitude is same as displacement. So at t is equal to 0, this term becomes 1. So phi is equal to amplitude. So these two curves, so this green curve represents phi naught e raised to power minus beta t, and this blue curve represents the whole displacement. So you can see that here they will overlap, but the actual peak of the displacement will come a little bit before that. Anyway, it's irrelevant, but you should know how to draw the curve. Now we need to find phi dot and phi double dot. So let's just differentiate these terms, and in a part we just put the values of t is equal to 0 in both the equations, and we'll get our answer. So here also you can again see, even though cos omega t reaches its maximum value at t is equal to 0, still phi does not reach its maximum value, because if that would have happened, then phi dot should be 0, but phi dot is not 0, it's negative. So the slope here is negative, so the maximum value came a little bit before. So at this point phi dot would have been 0, but not here, even though cos omega t reaches its maximum value. Now in B part, the time at which angular velocity becomes maximum. So angular velocity phi dot will become maximum when phi double dot is 0. And again, in a normal sine curve, this occurs when the curve cuts the x-axis. At those times, the slope is maximum. And when slope is maximum, that means phi dot is maximum. But here again, this curve is not your normal sine curve. So when you put the value of phi double dot 0, the answer you are going to get is when this term becomes 0, that is tan omega t is beta square minus omega square by 2 beta omega. So from here we get omega t is equal to n pi plus tan inverse of this, or at times of t is equal to n pi by omega plus 1 by omega tan inverse omega square minus beta square by 2 beta omega. So these are the points when the slope reaches its peak values. So you can just put the values of n is equal to 1 to 3, and that will give our answers. All right.